Hello friends, in this small video, I am planning to introduce probability theory in a simple way. Of course, probability theory is a bit complicated mathematical concept. Hence, students without mathematical background will find it as very difficult to grasp and understand these concepts. But if your aim is to use these concepts in statistical inference or statistical model building, we need not go deep into the mathematical concepts of probability theory. We need only the logic, basic concepts, and certain computational rules. In this scenario, we need not start from the set theory concepts. We need not go deep into the mathematical complexities. So, this is a humble attempt to introduce probability concepts without complicating non-mathematics students and at the same time maintaining the required rigor. I will begin this lecture by asking a simple question. What is probability? When I ask this question in my classes, a majority of students usually answer it as the number of favorable cases by total number of cases, limit of the frequency ratio, etc. etc. But this is not the right answer for my question. I asked, what is probability? The answers given were certain practical methods by which we compute probability of the events. Answer to my question is very simple. Probability is a measure of chance. Probability is a measure of chance defined by a set of rules. Why I am insisting defined by a set of rules? The reason is nothing but there is no instrument to measure probability. It can be done only by defining with the help of a set of rules. So, in this video, my agenda is as follows. I'll be providing you the basic definition of probability. We will be discussing computational rules. Then we will go to a specific rule known as addition rule. Finally, we will do certain simple problems to illustrate the concepts. Okay, probability is a measure of chance and this measure is defined by a set of rules. The next question is, what are these rules? They are very simple rules. The first rule is, probability should be a number lying between 0 and 1. This can be symbolically expressed as 0 less than or equal to PA less than or equal to 1. The second rule is, probability of non-occurrence of an event is 1 minus probability of occurrence. This can symbolically be expressed as probability of A complement equal to 1 minus probability of A. Finally, the third rule is, if A and B are two events that cannot occur simultaneously, then probability of occurrence of A or B is the sum of the individual probabilities. This can be expressed as probability of A union B equal to probability of A plus probability of B. Here A union B stands for A or B. Also, when I say A and B cannot occur simultaneously, it means A and B have no common points, or A intersection B is a null set. A intersection B is used for A and B. The next question is, how do we assign probabilities to events? This is to be done according to the situation. If we are dealing with an equally likely situation, that means a situation having equal chance of occurrence of events, we can use classical approach. According to this approach, probability of an event is the ratio of number of favorable cases to the total number of cases. For example, consider the case of rolling an unbiased dice. Suppose I define the event A as getting an even face, then probability of A is given by 3 divided by 6. We know getting an even face has 3 favorable outcomes, 2, 4 and 6, and there are total 6 outcomes. That is how we are getting the probability as 3 divided by 6. Similarly, suppose in a class of 60 students, 25 students got more than 75% of marks. Then probability that a student get more than 75% of marks is 25 divided by 60. If the situation cannot be assumed as equally likely, we can think of frequency definition or empirical definition. According to this definition, probability is the long-term frequency ratio. For example, assume in a customer satisfaction survey, 80 customers out of 500 liked the taste of a newly introduced soup. Then probability that a customer liked this soup is 80 divided by 500. Finally, we come to subjective probability. Here, the analyst has to assign probabilities according to his subjective judgment as per the information available to him. A doctor's diagnosis regarding a disease is based on subjective probability. In all the 3 cases, probabilities are to be assigned in such a manner that it satisfies the rules specified. We will conclude this video by defining a very important rule called addition rule. The rule says probability of A union B is probability of A plus probability of B minus probability of A intersection B. Please note that here there is no condition on A and B. Previously we discussed the case where A and B are having no common points. Now we are not giving any condition on A and B. That is why that minus A intersection B came. If A and B have no common points, naturally probability of A intersection B will be 0. Hence, the rule reduces to the previous one. Finally, let us take a simple example illustrating all these rules. Amazon in a recent survey identified that 25% of the visitors of their website purchases electronic items. 20% of them purchases personal care items. And 5% purchases both electronic and personal care items. The first question is, find the probability that a randomly selected visitor purchases A. electronic items, B. personal care items, and C. both. The answer is obvious. By applying classical definition, we get probability for purchase of electronic items is 0.25, personal care items is 0.20, and both is 0.05. The next question is, what is the probability that a randomly selected visitor does not purchase electronic items? Second one is, does not purchase personal care items. Here I can use complement rule. Does not purchase electronic items means complement of purchase of electronic items. So I can use it as 1 minus 0.25, that is equal to 0.75, 1 minus 0.20 equal to 0.80. Finally, the third question is, what is the probability that a randomly selected visitor purchase either electronic items or personal care items? Either or means A union B. Here I can apply addition rule. Probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Applying the rule, I will get the probability as 0.40. In the next video, we will discuss more concepts related to probability theory. Thank you once again.